Hi everyone. Right now we are going to see different types of contact analysis that can be done. Uh, a contact analysis is a non-linear analysis. The most simple type of contact analysis is two bodies touching each other. This is the most simple type of contact analysis. In this type of analysis, there is one body, there is one body, and there is another body. Both bodies touch each other, and there will be a contact between them. They transmit forces as well as they transmit friction, and there will be contact pressure involved at this zone. There is another type of contact in which there is contact as well as sliding. The most common example is a bearing. In the bearing, there is a bearing housing and there is a shaft inside this. The shaft slides inside this bearing housing. The shaft transmits the load and the bearing housing ultimately gets all the loading. The bearing is loaded. This type can be of two types of contact. There can be a structural loading as well as there can be a thermal loading wherein the shaft gets heated and transmits its heat or conducts its heat from the shaft to the bearing housing. We can see the different temperature plots on the bearing. We can also do a stress distribution plots. Electric motors bearings can be analyzed for loading coupled with heating. Inside you can see a sort of gearbox to which this application can be done. This is another type of non-linear contact analysis. This is sliding contact. Third type is interference contact. In this type, two bodies are penetrating with one another and these bodies have contact pressure. The most easy example of this is an interference fit or a shrink fit, wherein the shaft is of larger diameter, the hub is of smaller diameter, the hub is fitted over the shaft, and then there is a contact pressure in between these two. Now this can be analyzed by a contact problem. This also involves friction. Let us go on and see in a little detail how this analysis can be done. This analysis has been performed in a software called Salome Meca, which is a preprocessor, and Aster is a solver. You can see there are various stresses involved in this. Analysis has already been done. I am showing you the principal stresses. The red color are the principal stresses. These are the principal stresses. The third principal stress varies from minus 1.07 into 10 raised to 3 to plus 687. We can also have a clipping. This is a clipping. We can go in detail inside and see what are the stresses. I can also move this clipping. As the clipping moves, we can see the various stresses involved. This is a very interesting feature. This allows you to actually post-process in great detail. You can see the various stresses. It allows you to reach to various zones. Also, there is another function called slice. Slice is the slice of the shaft and the hub, both assemblies. It is taken in normal Z direction right now. It allows you to see the stresses in a sort of a slice mode. So there are different options which will allow you in this case also you can move the frame front and back so as to have a slice at that particular location. There is another option called as displacement plot. In this you can see there is a displacement. The hub and shaft have displaced because of the various pressures involved in this. This was a brief intro about contact analysis, interference contact. Let's get back to the presentation, what all things can be done. So coming back from the contact, fatigue analysis can be done. Fatigue analysis is very important analysis. It will help you to calculate the number of cycles before the fatigue failure you can make changes for the design. Optimizations can be done. If you have a number of geometries, one can make changes in them and see which geometry gives the least stress. This is another optimization problem which you can see. Then there is a multi-physics problem which can be solved, especially in the case of a motor. This is especially useful for current carrying devices which get heated and need to be cooled by a fan. Whenever a current flows through a coil, heat is generated. This heat is generated on account of Joule heating. This can be simulated. We can find the heat source, and we can optimize the fan speed so as to reduce the parasitic power consumption and to improve the motor efficiency. Various problems can be solved. For example, I have already shown you about the contact analysis in some detail. Then thermal is very important part. Thermal temperature, forced convection. As I told about heating by Joule effect, this is another. Electromagnetic forces, this is also used for motor. These all are important. These all types of analysis can be done. Mechanical, static, quasi-static, dynamic. So this all type of analysis can be done. The tool that was used for pre-processing was Salome Meca, and the solver was Aster. It is an open source solver. This was all about the analysis. Thank you for your time. Thank you very much.